All right, let's start with a warm-up question. This is going to help you maybe with some issues that you may have had on last night's homework, or maybe will in the future. And this is a question that's almost straight off of your test. So let's take a look at this. This is a factored form of a polynomial. It's not on any worksheet, guys. This is just a warm-up question for y'all. It's in factored form. So if I want to perform the leading term test, I have to do a little investigating as far as like what the leading term is. So this factor right here is a monomial. So I'm just going to write down negative 4x squared. But this factor, obviously it's a binomial, but all I really care about is his leading term, so I'm just going to write down the x. But be careful on this last one. It's a binomial squared, so ignore all the other components of the binomial squared. What would just be the leading term of this? Like if you FOILed it, what would be the very first term? X squared. So what you truly have in this problem as far as leading terms go is you have a 4x squared times an x squared. What does that become? Negative 4x to the fifth. Very good. So your true leading term, I don't care about the rest of the polynomial, just that leading term is negative 4x to the fifth. So this should be a quick, easy question for you now that we have that. Who is the degree? 5. What is the leading coefficient? Negative 4. It doesn't ask this, but I'm going to ask it anyways. How many possible zeros do we have? 5. And then how many turning points could it have? Good. One less than that. Very good. All right. End behavior. Since it's a degree 5 with a negative leading term, that means your left end is going to go up and your right end is going to go down. But remember PreCalc, we have to actually write end behavior out. So we're getting good at our template. On the left side, where it says as x approaches negative infinity, oops. On the left side, how do we indicate that it's going up? What do we write? Positive infinity, good. And then on the right side, where x goes to positive infinity, how do we indicate it's going down?
Negative.
Very good. Well, we're not in 4th grade yet. That's the second half of the lesson. All right, zeros, including multiplicity. So now you go back to the factored version of your polynomial, because they already had it factored for you. If you were to set this guy equal to 0, what solution would you get for your 0? You'd get 0, right? Negative 4x squared equals 0. You divide by negative 4, you square root. So you get x equals 0 as a 0, but how many times does it show up algebraically?
Twice.
So you write multiplicity 2. You guys see why Cameron said twice? Was it Cameron or Adam? Which one? Okay. So he said twice because of the degree over here. It shows up twice. That's what that means. All right, how about this factor right here? If you have a factor of x plus 2 and you set it equal to 0, what 0 do you get? Negative 2, and that just shows up once, so we don't have to write anything. What about this factor? What 0 does this one provide you? 3, good. How many times? So you write multiplicity 2. So that's kind of the basis of the last couple days lesson of if you have a polynomial, once you go to find the factors, if you're looking at it algebraically, you might have to indicate how many times it shows up for me. Today we're going to talk about what that looks like on a graph. I'm not going to graph this one. No, thank you. All right, find worksheet 4B. This is an assignment for you. We're going to do numbers 1 and 4 together, and then you're going to do the rest of them on your own. And we're not going to spend a great deal of time like trying to make them look pretty, and I'm okay with that. All right, so number 1. First thing I want you to do is go through and find all of your zeros. So they didn't really tell me this here, but I'm assuming that this guy right here is exactly at negative 2. And then this one right here, they did label for you. So you have a 0 at x equals negative 4/3. And then this one is also labeled for you. This is at x equals 1/3. So what I need you to do next, and there's going to be a little bit of work, so write kind of small. You're going to write a start of an equation. Put down a variable a, because I don't know a yet. And now I want you to think backwards. If you know you have a solution at x equals negative 2, what does that factor look like? X plus 2. Very good. And then if you know you have a solution at negative 4/3, for now, what I'd like you guys to write down is just x plus 4/3. We'll talk about other ways we could have written that in a moment, but for now, just write it like this. And then if I know I have a solution at 1/3, I'm going to write the factor as x minus 1/3. So that's looking like an equation. The problem is you don't know that great a value. And remember, whenever these problems come up for writing equations, you have to do a little bit of work to find the a value, which means I had to give you another clue. There is another clue sitting on your paper right here. It says when x equals 0, the y equals 16. So we're going to plug in 16 for y. I still don't know a. But now you're going to plug in 0 for all of those x's. And then we're all going to grab our calculator probably because no one wants to do this in their head. Although I will say I totally did this in my head. Nope. You got to multiply, multiply, multiply. Yeah.
What an idiot.
Oh, you're not an idiot, Daniel. You're a smart guy. All right, multiply these together for me. Story of our lives. I think you get negative 8/9, but someone double check that. Okay, good. So now let's bring it back to 4th grade. How do we solve for a? Because we're not going to divide by fractions because we don't actually divide by fractions. We multiply by the reciprocal, so multiply by negative 9/8 on both sides. This side over here becomes, what is this? Is that negative 18? Oh, lovely. All right, so you just found out that your a value is negative 18. Now, if you were very, very smart and did your math in pencil, all you'd do is you'd simply come back up to here and you'd throw a negative 18 in place of the a, and you're done. If you didn't use pencil, you have to rewrite all of that. Haha. Okay, now, did anyone think of another way of writing this factor right here? Because we usually don't have factors like x plus a fraction. That's kind of weird. Anyone have another way that you would get an answer, a solution of negative 4/3 having a different looking factor?
I don't really know what you're at.
That's okay. What about this? Wouldn't this factor give you negative 4/3? It looks prettier, doesn't it? Okay. Now, if you did that technique, because I had a kid last hour who's like, oh, I wrote down 3x plus 4, because he's right. That would give you that same factor. So I'm assuming he also did it over here. He probably wrote this as 3x minus 1, and then x plus 2 is the same. So if he wrote them that way, he's actually going to get a different a value. And here's why. If you take, don't do this, by the way, in your paper. Just some of you are like, wow, that's a lot of thinking. You don't have to do this on your homework. If you had a fraction term here, you could take a portion of the 18 and multiply it into this fraction term and create pretty numbers, integers. So like for instance, if you multiplied everything up here by a 3, this becomes 3x plus 4. But you just took 3 away from this, right? So this is already a negative 6. And then if you did the same thing here, you multiplied this by a 3, it becomes a 3x minus 1. But you took another 3 away from it. So his a value came out to a negative 2. But he found that the same way we found our a value. He just had totally different math because he interpreted the factor a little differently. So our original answer of negative 18 with the weird fractional looking factors is a great answer. The answer that the child in first hour came up with, the negative 2 times the pretty factors, is equivalent. It gives you the same polynomial. Okay? Don't bother finding pretty factors today would be my advice to you. I don't think it's worth it. But if you're just so good at math that you can do that in your head, good for you. All right, number 4. This time, we got a whole lot of intercepts to talk about, guys. Let's talk about this one. Your 0 is clearly at x equals negative 3, but what do you notice happens on the graph at x equals negative 3? It's bouncing off, right? So because it bounces off the x-axis, that means you have even multiplicity. Pre-calc, we're not going to get crazy and give you weird multiplicity. If it bounces, just assume it has multiplicity too. Okay, anytime you see a bounce off the x-axis, multiplicity 2. What about this x-intercept? This is at 0, and it crosses through, so we're just going to assume that happens once. And then this time, you have another bounce. So while you do have an x-intercept at 5/2, we have to make a little note to ourselves that we're going to have multiplicity 2 again. And here's where we get to have fun writing our equation. Here we go. Ready? Y equals I do not know the a value, but I'm wondering if you could give me some factors. So right here, guys, if you have a factor, a solution or a 0 at -3, what does your factor look like? X plus 3, good. But we also noted that it shows up how many times? So put a 2 exponent on it, please. Yes, Damien?
The risk of sounding like a stupid person. What does multiplicity 2?
It means the factor shows up twice in your math. So like it's going to show up like this in the algebra.
Okay.
And when you look at your graph, while they are both solutions or zeros of the function, because it shows up an even number of times, instead of crossing through the axes, it bounces off. That was our lesson yesterday. Okay. All right, so the next one, x equals 0. You can just write x, but I had a lot of kids say, can I write x minus 0 just so I keep it consistent? And I said, yeah, of course. All right, and then the next one, your factor for a solution at 5/2, your factor would be x minus 5/2. Leave it ugly. But it does show up twice because it bounces off, so put a little 2 exponent on that one. And now we get to have fun. There's some other ordered pair sitting in your problem. Do you see it? It's a beautiful one. When x equals 1, y equals -28.8. Okie dokie. Well, no, because we already used it as a 0. So that's a good question, but no, you can't. It has to be a non-zero. All right. I promise you this one will work out pretty decent. The fraction that it comes out to isn't horrible. But first, let me write. All right. Everywhere you see an x, I need you to plug in a 1. You could leave, again, the -0 off. Okay, this time I'm not trying this in my head. I need you guys to figure out what this coefficient is. Uh-oh, it's about to do something weird. Yeah. Oh, like change to green. There we go. Type this in your calculator, please. Get my work up. Is it 36 or something? Okay, cool. One more step and then you have your a value. Again, it looks kind of gross. Fraction or decimal answer here. It's a pretty decent decimal. And since they already gave me a decimal for a y value, I feel like we're okay to use it. Is it -0.8? I hope. So then if you used pencil, you would just come back right here. And you would erase where you had a variable for a. And you'd fill in this -0.8 that you just got. What? Did you divide them backwards? It's -28.8 divided by 36. Yeah. Oh, that sounded like a baby.
Baby?
Yes, calculators are my babies. The ordered pair at the beginning of the problem, that wasn't one of my x-intercepts. It says right here when f of 1 equals -28.8. So that's the ordered pair I used this time. Okay? So these have a little work to them. You guys are going to finish up 4B as part of your homework check. If I look ahead, the only other one that has multiplicity, I think, is number 5. Do you see it right here? So x equals 2 shows up with a multiplicity of 2. Very good. So keep that in mind when you go to write the equation for number 5.
So you either have multiplicity of 1 or 2?
For these problems, it'll just be once or twice. Yeah, I'm not going to trick you. If it had multiplicity of 3, that's very difficult to see in a graph.
Yeah, how do you see that in a graph?
It still crosses through, but it kind of like hangs out for a while at the axes. But like I wouldn't expect you guys to notice that.
Oh, so it's the ones that like...
They they kind of like sit along the axes and then they keep going. Yeah, exactly. So that's nothing I would expect a pre-calc kid to like see off the top of their head. Like, clearly that has multiplicity of 3. Like, no.
And
So
if it sits along the axis, is it always 3?
It could be 5, it could be 7. Yeah. So if you guys ever just graph like a really boring like x to the 3rd power or x to the 5th power, it seems like it kind of like almost flattens out at the origin area, and that's what's happening. It's creating a lot of odd multiplicity, and it's just kind of there, and then it eventually goes through. The graph doesn't look great. They look weird, but I don't expect you guys to know that. So for these questions, yes, it'll either be multiplicity 1 or 2. Well, we don't say multiplicity 1, but yeah. You finished worksheet 4B for part of your homework assignment tonight, and now we're going to bring it back to 4th grade. Who doesn't like a good long division question? What? Like, I don't even know how to relate to you children. Yes, you did. Let me tell you. Well, okay. Well, 4th or 5th grade. Well, I don't know. It depends on your school, I suppose. I distinctly remember having to stay in for recess for long division because I couldn't get it. And now here I am teaching you all how to long divide. All right, so now that you're older and wiser, we can kind of give you guys a little more reasoning as to why the long division process works rather than just like, can you please blindly follow these 4 steps? So we're going to talk a little bit about that. And actually, I would argue long division in algebra is easier than 4th grade long division. Because in algebra, you just have to worry about the lead terms and do very minute calculations. In 4th grade, they made you do a whole bunch of calculations. Like, let's review what we did in 4th grade, y'all, or 5th grade. Without a calculator, your teacher would say, please divide 293 by 6. So the first step, they would say, look at a smaller division problem. So they would say, instead of 293, just look at the first digit or 2. So we had to look at the first 2 digits in this case. How many times does 6 divide into 29 without going over? 4 times. So then your next step is to multiply. And the reason you're multiplying is you're trying to see like how close you are to the true answer. So you're multiplying 4 times 6 and you get a 24. And then how far away are you from the true answer? This is a creation where you have to subtract. You got to find the difference. So the difference between where I want to be and where I am is 5. But we know now that we're older, this 5 really represents 50 because of the digit. So then we drop down the 3, and we can see we're really now dividing a 53. So you created a smaller number. Do you guys recognize when you did that 29 divided by 6, you really were taking 290 divided by 6? Because it's really in the 40, yeah, it's in the 10 spot, yeah. They don't tell you that when you're 10. Because, like, when you're 10, you'd freak out.
Unneeded information.
Right.
As a 10-year-old.
Well, as a 10-year-old, that's not, yeah, it's too much, okay? But we're older, we're wiser, we got this. All right, so the process starts all over again after you bring down the next term. All right, so then you have a smaller problem, still 53 divided by 6, and then, so you got to think, because you don't have a calculator, and you're like, 8 times? So 8 times 6 is 48, and then we're going to see how far away we are from the true answer. And I think we're left with a 5. Now, this is in 4th, 5th grade. Your teacher sometimes let you stop. And then they had you write 48R5. Now, tell me ever in your life, have you ever seen someone do a real life calculation and they came back with 48R5? This doesn't mean anything. This is like complete gibberish that only makes sense to 4th grade parents, students, and teachers. What is the actual answer? So your 4th grade teacher may have then taught you to put a decimal point, put some trailing zeros, and then they made you keep that party rocking. You had to keep bringing zeros down, and you were like, this is never going to end. And in this case, it does end, eventually. But here's what they should have taught you in 4th grade. The reason it's a remainder is because it's still stuck in the division loop. So the true answer is that 6 goes into 293 48 times with 5/6 remaining. That's the answer. It's a mixed number, 48 and 5/6. How simple would that have been to tell a 9-year-old? I feel like they don't give them enough credit. Like, it's a fraction remainder. It's almost there, right? 5/6 is real close. Like this close. So in PreCalc, when we do polynomial division, this is how I expect you to write your answers, as what look like mixed numbers, but for us it's going to be a polynomial with a fraction remainder. Oh, speaking of, yeah, okay. So we got long division. We got long division and we have synthetic division. What does synthetic division mean to you?
Terrible.
Synthetic is terrible?
I don't remember which.
Oh, well, what does the word synthetic mean to you?
Fake.
So, yes, true. It is we're all man-created though, right? So, long division, the reason no one likes long division is because it requires you to essentially, on a polynomial level, it requires you to divide and subtract. And someone in the history of math was like, yeah, you know what? Division and multiplication are actually the same thing. Like they're inverse operations to each other. And addition and subtraction are the same thing. So some bright person was like, why can't I just change the process so I multiply instead of I multiply instead of divide, and I add instead of subtract. And then everyone was like, yeah, that's better, because we'd much rather multiply and add. So that's the creation of synthetic division, and turns out synthetic division is actually quite cool. It gives us some other things too. And I know you guys are like, oh, I love synthetic division. I hate long division. Well, on your test, you're going to be asked to do one of each. But there will be a time in our future where we just have to divide, and it's up to you how you divide. So I expect every person in this room to probably choose synthetic division at that point because it's easier. It's easier. You can choose long division. You know what? Long division is kind of my jam. So sometimes I just do long division for fun. And there are cases where synthetic division doesn't work. It doesn't work and it's not effective. So we do need to teach you both. All right, you are just watching me do this. It's already done on your notes. So your 4 steps for long division from 4th grade. Your first step was to divide. So this is why I argue with children that algebra long division is easier than 4th grade long division. When I divide, I take just the leading term of your dividend, and I divide it by the leading term of your divisor. That's it. You don't have to do the trailing terms. So all I'm asking you to come up with is what is 3x to the third divided by x? What does that simplify to? 3x squared. And we write the answer to our division up at the top because that's where our quotient's going to be. So now I want to see how far away I am, so I multiply. So the 3x has to get multiplied by the entire divisor, so I usually encourage my kids to put parentheses around this divisor so they know to distribute it all the way through. So this is 3x to the third, and then plus 3x squared. So that's what I have right now. Let's see how far away we are by subtracting. So this is where everyone messes up in Algebra 2. Even though I tell them to do this, they forget or they don't do it for some reason. You want to use parentheses around that, and you want to draw a break in your math. The lead term here, when you subtract them, they better cancel. If they don't cancel, you've done something wrong. So lead term's gone, but don't forget you're subtracting. 0x squared minus 3x squared is a negative 3x squared. And then you have more terms remaining, so you're going to bring down your next term with the sign and everything. And now we start the process all over again. So you started with what was a pretty large polynomial, and you're just whittling it down to a smaller and smaller polynomial. So your new lead term that you're going to divide is the negative 3x squared. And when you divide it by the lead term of your divisor of x, what are you left with? A negative 3x. Very nice. That gets written at the top here. And then the process continues again. You're going to multiply the negative 3x by the divisor. Thank you. And then you get, where are we at? Negative 3x squared minus 3x. Okay, don't forget you're subtracting that entire quantity. Please use your parentheses when you subtract. The lead terms should cancel, and they do. And then negative 2x minus negative 3x is a plus 1x. Thank you. Bring down, you still have another term, so you got to bring down your next term. And then you start it all over again because this is a pretty large polynomial. So lead term only, x being divided by the divisor's x gives you a 1. So a sign with it is a positive 1. You multiply the 1 by the divisor. You get an x, what is it, plus 1? And then when you subtract this, the lead terms cancel like they should. Negative 4 minus 1 is a negative 5. Who is this? This is my remainder. But we don't write our negative 5 because that's gibberish. So we go back up. Whoops. We go to our quotient. So far it is 3x squared minus 3x plus 1. How do you write the remainder then? Because he's still stuck in the division loop. So you can say plus negative 5 over x plus 1. Most people will change that to a subtract 5 over x plus 1. That is your quotient. Okay, remember doing that? And the work looks so pretty when you do it in colors. Like if all you have is one color, the stuff I have done in red, I would do that in a color. Like if you have one colored pen that you're working with, I would at least do that. Let's take a look at me doing a synthetic one, and then you can make your own decision as to which one you like better. Synthetic, the math is easier, but the setup and the interpretation of your answer is crucial. So a lot of kids think synthetic is the way to go, but they don't remember how to use it. So you start by setting up a weird little half box. And then, do you remember what I place in the half box? The solution to your divisor. So if you were to solve and find your solution to your divisor, you'd put a negative 1 there. And then you're going to line up your coefficients to your dividend. Make sure it is in standard form order, and that includes anything that's missing. So we're going to be using a 3. And then what?
0.
0. Why is 0? There is 0x squared term. Okay. 3, 0, -2, and a -4. And that's a very crucial mistake that happens in Algebra 2 more than anything else, is they forget those placeholders for the missing terms. So now, we know the math is going to be easy, but you still have to get it started. So you start by bringing down your first term as a leading coefficient, and then we multiply. So you multiply these together and you get a -3. Do you remember what we do here? Yes, we add up the column and you get -3. And then you just do those two steps over and over and over again. So -3 times -1 is a +3. We add them up and we get a 1. And then 1 times -1 is a -1. And we add those up and we get -5. And this last thing you get is called the remainder, which we know that. And later on we'll learn it's something else. What's remaining here, though, are the coefficients. These are just the coefficients to your answer. So now you have to interpret that for me. So what I do is I go back to my problem and I look at just the lead terms. You took a 3x to the 3rd power and you divided it by an x to the 1st power. Your lead term better be 3x squared or you have messed up. Good news, we have a 3. So this is 3x squared, and then trail down the line, minus 3x plus 1 is a constant. And then with the remainder of -5, you can say plus -5 over, I'm just going to simplify that to a minus 5 over, who is it still being divided by? X plus 1, the full divisor that we started with. Okay, this guy, which I kind of crossed off. Okay. Clearly, there's less work in synthetic division. Everyone liked it better. It seems simpler, but it has more interpretation to it because it's a very unique process that has been designed in a way where it works, but by a very crafty math person, right? So you don't get the choice of which method you use. Sorry. Sorry. Let's take a look at number 1. We have a divisor, a pretty decent sized divisor here, or a dividend, excuse me. 2x to the 3rd plus 3x squared minus 8x plus 3. All that underneath your little quotient house here. Whoop. I encourage you guys to put your divisor of 2x minus 1 in parentheses. All right, 4 steps. Here we go. First step is to divide. So 2x to the 3rd divided by your your coefficient of your divisor. What are you left with? X squared, x squared, x squared. Very good, x squared. So now we're going to multiply and see how far away we are from the true answer. So multiply that and you get, let's see, 2x to the 3rd minus 2x squared. So now we see exactly how far away we are by subtracting. It's 5x squared, isn't it? These are going to cancel and you get a 5x squared. 3 minus -2. Oh, that's not 2. Shut up, Abruzzo. You don't know what you're talking about. I just make it up numbers. This is a 1. But it's negative, right?
So lost.
I'm lost.
What did I do wrong?
I have no idea, but I'm utterly confused.
Did I mess up?
I don't know if you messed up.
Okay, what I have in green here, is that what you're questioning?
I'm
questioning the whole thing.
Okay, x squared multiplied by this is what I'm writing in green.
Oh.
Okay?
Okay.
So that's a 4x squared when you subtract them.
Okay. How do you get 2x?
Well, because originally I wrote down a 2 for no reason whatsoever. I wrote down a 2 right here.
I got that before you wrote down the 2.
Oh, maybe you told me to and you're the problem. Okay. Are we good now?
Wait, where'd you get the negative?
That's the subtraction step. Okay. So we got to bring down our next term so we can keep chipping away at this polynomial, and now we start all over again. You have a new leading term to divide. So your 4x squared being divided by a 2x gives me a positive 2x. So then the positive 2x is what we distribute into the divisor now. So that gives me a 4x squared minus 2x. Let's see how far away we are. Oops, I forgot to write my fourth step over here. Bring down was our fourth step, huh? All right, so lead terms cancel, and you end up with a negative 6x, yes. We have one more term to bring down, and this will be our last step in division. So dividing my new lead term by your 2x, I heard is a negative 3, so up top here we write down the minus 3, very good. Multiply that in. Whew. All right, so we have negative 6x plus 3. Hot dog, what happened to your remainder?
Beautiful.
You got nothing. You got no remainder. So your answer is? Yes, that's so nice. Look at that. Those are a hoot.
That was so cute.
Wasn't it cute? So colorful and pretty.
It's just so satisfying. Didn't know
You know, yeah, it is. It really is. Sometimes,
Wait.
yeah,
Not that math is satisfying. It's just
maybe.
Sometimes you gotta take the best out
Number
of your
two is making you
system.
sad, but it shouldn't. The larger your divisor, the less work you're going to have. So, yay for large divisors. Here we go. 2x to the third plus 5x squared minus 7x plus 6, all that being divided by this large and in-charge divisor of x squared plus 3x minus 4. Please put parentheses around that. All right, so first step is for us to divide these, and we're not going to have many more steps after this. What happens when you take 2x to the third and divide it by x squared? So now we're going to multiply the 2x by the entire divisor, the whole thing, and you get 2x to the third plus 6x squared minus 8x. We're almost done. Okay, we're going to subtract. Only your lead term needs to cancel, and it does, so we did something right. So these are gone. You have 5 minus 6, so you have negative 1x squared. And then careful here, this is negative 7 minus negative 8. So that's a plus 1x. Good. Bringing down your last term. Whoops, wrong color. Bringing down your last term. And then we're going to be done after this next step. So negative x squared, new lead term, divided by the positive x squared from the divisor. That comes out to negative 1. All right, let's do this. Negative 1 times this. It's negative x squared minus 3x plus 4. All right, subtract all that. Now this time you do have a remainder. It's kind of weird looking. You have a 4x and a plus 2. You can have polynomial remainder pieces. It's okay. 1 minus negative 3. Did you have a negative 3 right here?
Yeah, but
1x minus negative 3x.
1
minus negative 3.
That'd be 4.
Yes. Okay, so our answer is 2x minus 1 plus this 4x plus 2. Who's he still being divided by? Yeah. And then you're like, well, that's cute. Sure, that's our answer, right? And it is actually your answer, but I want to warn you about something that shows up on your homework. That remainder, do you notice anything about it?
Our answer times 2.
It's factorable. It does have a relationship to the whole part of the quotient as well, yes. So what you want to get in the habit of doing is if you notice your remainder is factorable, which in this case it is, you want to try factoring it, because I know in your homework there's a question where something cancels. So like right here, if we factored that numerator and we factored the denominator, what would that be, like x plus 4 times x minus 1? So nothing cancels in this question, but I'm glad you guys tried it, because if something does cancel here, you're going to need to cross it off. So on your homework, I believe there's one question where you have this weird remainder with this weird divisor that's a polynomial, and you can factor it and cancel something out. So if you're wondering why you don't match the key, that's why. Maybe you have to factor it still. So as far as this problem goes, this is your good answer right here. You don't have to factor it. All right, real quick, synthetic. We love synthetic. as long as we remember how to do it. So, what goes in the little weird half box? Not x plus 4, but... not 4. -4, the solution to your divisor. If you were to solve your divisor by setting it equal to 0. Now your coefficients, again, watch out here. It's a 1. 0. -28 and -48. And then everybody loves synthetic division until you forget how to do it. That's a problem. All right, bring the 1 down. Let's get this party started. Multiply. 1 times -4 is -4. And then you add them up, and you get -4 in that column. All right, -4 times -4 is 16. Add those up, and you get a -12. -12 times -4 is 48. Oh, looky there. You got no remainder. So you're still not out of the woods because you have to remember how to write your answer. So your original problem was an x to the 3rd divided by an x to the 1st. So my leading term had better be 1x squared, or I have done something very weird. It is a 1x squared minus a 4x minus a 12 with no remainder, so this is your quotient. The next question, let's see if we can speed through it. Ready? What goes in the box?
1.
+1. Very good. The solution to your divisor is a 1. Coefficients. What you got?
1, 0, -3, 0, 12.
Nice call. 1, 0x to the 3rds, -3x squareds, 0 x's, and a 12. And that goes all the way down to the constant. Don't forget, guys, you got to bring it all the way down to the constant. It's a lot of ones, yeah. It's a lot of ones. All right, 1 times 1 is 1, 1. 1 times 1 is 1. Oh, -2. -2 times 1 is -2, -2. -2 times 1 is -2, that's 10. All right, so this doesn't mean anything. If you remember, this is your remainder, and if you remember you took x to the 4th and divided by x to the 1st, now we got this. We have an x to the 3rd, so this is 1x to the 3rd plus 1x squared minus 2 x's minus 2 for a constant. How you write your remainder, children? Good. Plus 10 over -1. Thank you. I crossed it off halfway. I couldn't read it anymore. Whew. We all love synthetic division. You don't get a choice on the test. You have to do both. Synthetic is better. But like a little part of me like wants to conquer long division because of all those recesses I missed in 4th grade. Yeah, I had to stay in for recess. It was rough. It was a rough go. But look how good I am at it now. The power of yet, children. The power of yet.